Okay, let's unpack this. Peanuts. You probably eat them, maybe have a jar in the pantry right now. But do you actually know the really wild story of how they grow?
It's quite something, isn't it? Almost like science fiction in some ways.
Yeah. So today we're doing a deep dive into the peanut plant's life cycle. We're focusing specifically on that journey from flower to, well, peanut. And we're using observations from a gardening journal, tracking plants about a month after they were sown.
Right. And the mission here is really to get our heads around this pretty unique reproductive process.
And figure out where peanuts really come from, because it's probably not what you think.
Definitely not. What's so interesting, I think, is how this plant, Araki's hypogaea, it's a legume, technically it just sort of defies our usual assumptions.
How so?
Well, you think of fruits or seeds, right? You picture them hanging on a branch, maybe on a vine, out in the open air.
Sure, like apples or tomatoes.
Exactly. Peanuts, they do something completely different. And the source notes, they really capture the start of that.
Okay, so the journal points to this key moment, maybe 28 to 40 days after the seed sprout. That's when the first flowers show up.
Huh.
And it notes these little yellow flowers, distinctly yellow. And importantly, they seem to pop up mostly on the lower parts of the plant.
That's right, yeah. They tend to emerge from the leaf axils low down near the base of the stems. But here's where it gets really remarkable, and the source details this part well. These flowers, they don't stick around.
Yeah.
They're on this incredibly tight schedule.
Okay, this is the bit that sounded almost unbelievable when I first read it. The journal says these yellow flowers open up at night. Then they self-pollinate really early in the morning,
Right.
and by the evening of that same day, they've already withered away, gone.
It's almost frantic, isn't it? A single bloom exists for, what, less than 24 hours?
Wow.
Just long enough to do its job, pollination. You know, think about other flowers, roses, apple blossoms. They can last for days.
Yeah.
The peanut flower gets one shot, one day. It really highlights how optimized the plant is for reproductive efficiency when the conditions line up.
So, okay, this super short-lived flower gets pollinated.
Uh-huh.
Then what happens? You don't see little peanut pods forming right there where the flower was, do you? Hanging off the stem.
No, exactly. And that's the counterintuitive part you mentioned. This leads us straight into the next critical stage. It's called pegging.
Pegging.
Right. So after that successful pollination, the base of the flower, the ovary part, it starts to elongate. It forms this structure. The source calls it a specialized stalk. That's the peg.
The peg. Okay, and this is where it gets even weirder, right? Because most plant parts grow up towards the sun.
Precisely. But this peg, it does the complete opposite. It grows downwards, actively reaching away from the light.
Down, towards the ground.
Yes, it's what we call positively gravitropic. It responds to gravity growing down instead of being phototropic, growing towards light like most shoots.
That's wild. So it's deliberately growing down.
Seems like it. It's fundamental to the peanut's whole strategy.
Okay, so it's like the plant is trying to bury something. How far down does this peg go? And what happens when it actually hits the soil?
Well, it keeps growing down until it penetrates the soil surface. It can push down, several inches into the ground sometime.
Into the soil itself.
Uh-huh. And this is the crucial step. Once it's safely underground, the tip of that peg, remember, that contains the developing ovary, it starts to swell up.
And that's swelling. Underground.
Look at it.
That's it.
Okay.
That's the peanut pod. The thing we dig up.
That is exactly right. The actual peanut pod, the shell with the seeds inside that we eat, develops entirely below the ground at the end of this peg that grew downwards.
So hang on. The flowers are visible above ground, but only for a day.
Right.
Then this peg stalk grows down into the earth. And the actual fruit, the peanut, forms completely hidden underground.
Yep, hidden away in the soil.
Wow. Okay, that completely changes how you picture it. You're not picking peanuts off a bush. You're literally harvesting them from the ground.
It totally flips the script on how we usually think about fruit development, doesn't it?
Yeah, it really does.
And you can see the advantages, maybe. Evolutionarily speaking, protection from things eating them above ground, maybe a more stable environment down there, temperature, moisture.
Makes sense. Better access to soil nutrients too, perhaps.
Possibly. It's just a really remarkable adaptation, however you look at it.
What an incredible journey. You start with this.
Yeah.
Like, blink and you miss it. Yellow flower low on the stem.
Yeah.
Then this stalk actively pushes its way down into the dirt. And only then does the familiar peanut pod actually take shape, hidden away.
It's really a testament to the sheer diversity of strategies life comes up with, isn't it?
Absolutely.
So maybe something to ponder is this unique survival mechanism. Why evolve such a, well, seemingly complex system just to bury your own offspring?
Right. What does pushing its seeds underground tell us?
Exactly. What does it tell us about the trade-offs? The clever adaptations that let plants like the peanut thrive in a tough, competitive world. It's quite a thing to think about.